All right, so in this video, we're going to talk about solving linear inequalities with one variable, but also writing your solution in interval notation. So the solving linear inequalities is very similar to solving equations, and for the most part, people know how to do that. It's the interval notation that's going to be kind of the new thing for us. So what exactly is interval notation? Well, let's talk about just a general inequality. So we're going to have x is greater than 3. If we were to sketch a graph of this, so our 3 so if we mark our 0 is here, so 3 would be somewhere to the right of this. And we know from past graphing to graph this, it would be an open circle on 3 because x can be greater than x is greater than 3. It cannot equal 3, so it's greater than 3. So it's an open circle denoting it's not equal to. But then it's an arrow, since it's greater than, it's an arrow moving to the right. So graphing actually helps us just kind of visualize where this is at. Now, interval notation looks a little bit different. So what this is going to do is we're going to say, okay, x belongs to the group. So it's this weird looking E thing. And in fact, I have students that call it X weird E. So what this says, X belongs to the group or is an element of the group. And then we're saying 3, and then down here, this is like saying, okay, down here is positive infinity. It's moving forever and ever. Down on this end is negative infinity. So we start at 3, and we're going to positive infinity. So you can put a plus here, or you can just leave it as that. And then to denote the sides, it cannot equal 3, so we use a parenthesis. And infinity is always a parenthesis because infinity is not a number you can ever be. So just to kind of denote, if we have an open circle or if it's infinity, we use parentheses. If it's a closed circle, this is where it gets a little bit different, we use brackets. So let's talk about what one would look like with a bracket. Let's get all these pieces deleted here. All right. Let us assume that x is less than or equal to 4. So once again, here's 0. 4 is going to be somewhere to the right of it. And since it is less than or equal to, it is a closed circle on 4 because it can be 4. And then our line is going to be moving to the left since x is less than 4. So that's kind of our graph. Now, graphing is not a requirement. It, however, does make the interval notation a little bit easier. So if we once again put our infinities on here. So on this end, we have positive infinity, and on this end, we have negative infinity. Interval notation is always left to right. So we're going to have our x is an element of, and then what's the furthest left? So negative infinity, and then we can go to 4. But remember, we can equal 4, so this side will be a bracket, and infinity is always a parenthesis. So this is kind of our gist of interval notation. So let's solve a couple problems, and we'll kind of see how this works. All right, so let's solve our inequality and then write your answer in interval notation. Solving the inequality should not be that big a deal because for the most part, we've done this for several years. So let's distribute our 2. So we'd have 2n plus 6 minus 4 is less than or equal to 5n minus 1. So 2n plus 2 is less than or equal to 5n minus 1. So let's subtract our 5n, so we'd end up with negative 3n, and then subtract our 2, so negative 3. And then we'll divide by a negative. Now remember, when we divide by negative, it turns this inequality around. So we'd have n is greater than 1. Once again, graphing it is not required, however, it is helpful. So I'm going to mark my 0. 1 is going to be off to the right of this, and it is a closed circle, and it moves greater than, which means it's off here to the right. So our interval notation will then be x is an element of, we start at 1, and it can equal 1, so we use a bracket, and then keep in mind, here's our positive infinity, here's our negative infinity, so we're heading towards positive infinity, and infinities are always a parenthesis. So we solved the inequality, which gives us our set notation, and then now we're writing our answer in interval notation, just as from where we start to where we're going. Okay, now we have a compound inequality. So now we have 2 inequalities we're going to solve. So let's go through and do this real fast, and then we'll write our solution in interval notation, because this one will be a little bit different. The first thing I would do here is let's divide by 4. So we'll have x minus 1 is less than or equal to 5. So x is less than or equal to 6. And then over here, x, so if we subtract x is greater than 3. So it's one or the other. So an or, this one's a little bit trickier. This is kind of one of the special cases, but we'll go and do it. So here's 0, 3 is to the right of that, and 6 is to the right of 3. So what this says is x is less than 6 or equal to. So we're going this way. And then or x is greater than 3. All right, if this was an and, we would look for this overlap spot, and that would be our solution. But since it's an or, this actually means that anything fits. Can you think of an x value that does not fit the description of being less than or equal to 6 or bigger than 3? Well, there's not one. So anything is possible here. So our actual solution, I'm going to go ahead and graph this here. Our actual solution is anything on the number line. There is no restrictions whatsoever. Our whole number line is the solution. Well, how do you write that in interval notation? Well, keep in mind, down on this end, we have negative infinity. This end, we have positive infinity. So if I can be anything, that means I can be anything from negative infinity to positive infinity. And that is your interval notation. Let's talk about this one. So this one's also a compound inequality. You can see both of them are there. Let's go ahead and solve this. So I'm going to show a little bit of work here just to kind of help out. So if I add 1, I have to add 1 to all parts of this inequality. So I'm going to have negative 6 is less than negative 3/4 x is less than or equal to 12. My next step would be to multiply by the reciprocal, but when I do that, remember I have to do that everywhere. And it's a negative, which means all of my inequalities here are flipping the other direction. So negative 4/3 times negative 6, we know it's going to be positive, and it's going to be a positive 8. And then here we've got a negative 16, because a positive times a negative, and then x is in the middle. And now we're going to graph it, because that's going to be useful for us to actually see what the interval notation is going to be. So here's my 0. 8 is somewhere over here, and negative 16 is over to the left. And keep in mind, down here is negative infinity. Ooh, that's bad infinity sign. And over here is positive infinity. So let's talk about what this is doing. So 8 is greater than x. I like to think of it in reverse. X is less than 8. So right here, if x is less than 8, that means on 8, I have an open circle, and my graph is heading that direction. And here, x is greater than or equal to negative 16. That means I have a closed circle, and it's heading this direction. Now notice there's not an or anywhere. So what this is saying is x has to be in between 8 and negative 16. That means that we are going to actually have a line connecting these two pieces. So how does this work with interval notation? Well, we still have our x weird e. This time I start at negative 16. It can be negative 16, and then I end at 8. But it cannot be 8, so I've got a parenthesis. So that's my interval notation for this. All right, so then we talk about our domain rules, because what we're going to be doing here is we're going to be asked to find the domain of these expressions. Remember, domain is all your possible independent variable options, or what are the possible x values. There's only a few things that actually affect the domain, and it's fractions and even roots. There are some other things like logarithms and stuff like that that will affect it, but for now we're really just focused on the fractions or the even roots. So here's kind of our flow chart of questions that we ask. Is there a fraction? Yes or no? So you can kind of follow the direction there. And then the next question is there an even root? So the answers from those would be yes or no. And then from each of those, it tells you what to do. So if the answer is yes, yes, then you're going to set the denominator not equal to 0 if the root is on top. And then you would also, and then if the root is in the denominator, typo, you're going to set the inside greater than 0. Now, if the root is in the numerator, you would also have to set the root greater than or equal to 0. Now, it's kind of over here a little bit. So this one, it's not all inclusive, but this just gives you a general idea of where to go. So let's look at an example here. And I do have other videos that walk you through each of the types of problems and go through the domain rules a little bit more in depth. So find the domain of each expression. So let's talk about this first one. So the first thing we ask, is there a fraction? Yes. Is there a root, an even root? No. So we're going to set the denominator not equal to 0. Well, in case you forgot, the denominator is the bottom of the fraction. So our denominator here, so we're going to say 6a minus 3 does not equal 0. And the reason why that's the case is we can never divide by 0. The top can be whatever we want, but we can never have 0 as our denominator. It gives us an error, and you can't take something and divide it into 0 groups. All right, then we go through and solve this. So we'd add 3, divide by 6, so a does not equal 1/2. That means a can be anything else. So let's kind of see what this looks like on a graph, because that's kind of the fun part. Once again, here's our 0. Half is somewhere to the right. Then we have a positive infinity and a negative infinity. And you don't have to write the infinities. That's just to kind of help us visualize things. So a does not equal 1/2. That means it cannot be this. So we have an open circle, but the fun part about this is it can be anything else. That means I can be bigger than that, and I can be smaller than that. So I can be everything but that. Well, how do we write that in interval notation? That's going to be the fun part. So what we're going to say is we're going to have an x is an element of. Notice there are 2 parts to my graph. So I'm going to have 2 parts to my interval notation. So I'm going to just kind of do one part at a time, remember, from left to right. So I start at negative infinity, and I go to 1/2. It cannot be 1/2, so it's a parenthesis. Infinity is always a parenthesis. And then I do this u. This is also part of set notation. What this means is or. So x is an element of the group from negative infinity to 1/2, or I'm going to use a parenthesis because I can't be 1/2, but I'm going to pick it back up there and say to infinity. So once again, x is an element of the group negative infinity to 1/2, or from 1/2 to infinity, not including the 1/2. So that's our interval notation for our domain. So now let's talk about the next one here. So we have a root. All right. Is there a fraction? No. Is there an even root? Yes. So set the inside of the root to greater than or equal to 0. For the people who've got my actual note sheets that I handed out for my class, there is a typo on this. this does say just greater than, it should be greater than or equal to. So make sure you fix that on your domain rules. All right, so I'm setting the inside greater than or equal to 0. So what's inside? Well, the inside is just this 3 and minus 12, greater than or equal to 0. And the reason why it's greater than or equal to is I can square root 0, but I cannot square root a negative without dealing with imaginary. And we're looking for our domain for real numbers. All right, so then add 12 divided by 3. N is greater than or equal to 4. All right, so this one's going to be a fairly basic domain problem, but here, let's go ahead and sketch it out. So we've got 0, 4 is off to the right. Remember, infinity and negative infinity. It can equal 4, so it's a closed circle. And it's greater than, which means it's heading off to the right here. Ooh, bad arrow. So our interval notation is going to be x is an element of I can be 4, or x can be 4, and then it goes to infinity. So there's only one part of my graph. There's only one part of the interval notation. All right, now I want you to try this. So I'm going to have you actually pause the video. I'm actually just going to put the answer here eventually, but pause the video first, please. Okay, seriously, you haven't paused the video to try it, you probably should. But if you're going to not want to do that, that's entirely up to you. So our solution is another one where x cannot equal something. So x cannot equal 4. So it can be everything but 4. So we're going to say x is an element of the group negative infinity to 4 or 4 to infinity. So this is kind of the wrap up of part 2 of your homework. So I wish you luck.